optic flow. Just to keep things interesting, I didn't use the robot that I already had built from last year. And so I crazily decided I would build a new robot, and this is basically 2 days worth of work here, plus a little bit left over. I called it optic flow. I've got basically some mice sensors for optical mice on the bottom here that are ideally supposed to be keeping track of the floor moving beneath it. The hardware works, but it was another case of I tried to write the software while my wife was driving me here today. We drove down from Norman, Oklahoma, so it's a couple hours, but it's...
Good thing you got a wife.
Yes. Strangely, the code doesn't seem to be working right now, so we've gone to very brute force behavior. We're going to drive forward for a certain amount of time, and then we're going to drive backwards for a certain amount of time, and we'll see what happens. I also have a linear sensor on the front. This is basically like a camera, except it just senses one line. This is for the line following contest. Again, no software, but the hardware works, so maybe next year. I've got my own controller board here. I designed it for another contest that we did last year. It runs with an ARM-based processor from Luminary Micro. And the whole platform is basically just a base from Budget Robotics. It runs with modified servo motors. So that's it in a nutshell, what's happening here.
Okay. I'll give you a 3, 2, 1, and a go. Ready?
Yep.
3, 2, 1, go.
It's going so slow.
This is a new definition of quick, by the way. And we're probably going to hit the wall.
Oh, he's stuck. Okay, you want to give it another shot?
Yes, I think we'll just angle it off to the side.
Bowling is what we...
Okay. Yeah, so if my sensors were working properly, it would be able to tell that the right side was moving faster than the other. All right.
Ready?
Yep.
3, 2, 1, go.
And we'll see if this time...
Now he's scraping to the right.
Yes.
I think he's stuck.
Yeah. Okay.
Hey, you got one more try?
Yeah, let me go ahead and try that. Let's see what happens. Make sure the caster's lined up.
Ready?
All right, yeah.
3, 2, 1, go. All right.
Keep going, keep going.
Go, robot, go.
Cross the line.
Yeah.
Okay. See you when it comes back.
And we're going to hit the wall.
If only your wife had driven a
All
little
right.
slower.
He's stuck.
K2 was named by Randy Dumpsey because before it had any electronics on it whatsoever, it smoked. The battery wires just contacted each other randomly and it just started burning up. I wasn't going to enter Quick Trip, but I did, kind of in the grand tradition of the DPRG, that I had some old code on this for this robot that I have no idea if it's going to work or not, but 2 of the behaviors were wall following. So I've got the right wall following behavior turned on right now, and I'm just going to see if it works. I just did some changes just now that I think might have needed to be done, so we'll find out.
All right, I'll give you a 3, 2, 1, and a go.
Okay.
All right, 3, 2, 1, go. to explain what he's doing here?
Oh, sure. He's using his two rightmost sensors to kind of look ahead of him and kind of look to his right. And if he's getting his front end too far away, he's turning back into the wall. I think that's correct. But basically, he's using these two infrared sensors, which are infrared range-finding sensors. So they give me a distance about 4 feet maximum. But they actually give a determination. Now, it's really jerky here. I had some smoother code at one time. I don't know what happened to it.
All right.
Thank you.
Hey, am I on that list, guy?
Oh, I'm sorry, Ron. Yeah, you are. And I
Skipped you. I skipped you. Okay, that's okay.
Dale?
All right.
I'm also on the list.
Okay, I'll push you here. Are you ready?
Ready.
Okay, 3, 2, 1, go.
No.
I'm done.
Alrighty, no problem. Are you ready?
Yep.
Okay, 3, 2, 1, go.
That's number 2.
Up he goes. One, go. Oh, didn't cross the
Across the
line.
line. This coins of motors I bought surplus, and the motors have encoders where the robot knows how far the wheel has rotated. In fact, about 48, for every inch it counts up to the number 48. So if it drives 2 inches, it counts to 96 and so forth. So both left and right motors, the speed is monitored by the computer, and so to drive straight, the goal is to have the wheels rotate at the same speed, provided that the wheels are the same size, which they almost are. Anyway, this robot uses a little computer that a buddy of mine and I built. It took us a year to build the computer that's on top of it, although we made 1,000 of them. But anyway, to write the software and build the electronics took a year. But then separate from that task is the task of building the robot controller. And that, I don't know how much time I have in that, months, whatever it is. Anyway, so I'm going to fire this up. I have to adjust a few parameters, so it'll be a few seconds. I'll try not to take too much time up here. It has a little touchscreen interface, and I have to tell it not to drive 48 inches. That looks longer than 48 inches. So I'm going to try about 120. Let's see, that would be about 10 feet. That should be about right. Let's see. I'm going through a little menu here where I can enter my distance, 40 inches. Whoops, and hopefully I got it. Let's see what happens. Now I have to remember which command to get it to drive. 1 second here. Let's see, I think it's, yeah, okay, quick trip. Okay, here we go. Let's see, I think I'm ready.
Are you ready? I'll give you a countdown.
Okay.
3, 2, 1, go.
Okay, if this works, then I'll try it a little faster.
Oh, very nice.
Still backwards.